Okay, here we have our fourth section. We're going to take simple interest. We're going to start talking about compound interest, so it's not just the interest earned based on one computation and one principle. Here are a few things you need to learn in this section. Make sure you're taking good notes. Okay, so compound interest. Simple interest is just based on principle. Compound interest is based on principle, but then it's also recomputed after a certain amount of time. So you can compute interest on a balance, and then you get a new balance, a new principle, and you will compute interest based on the new principle. So it's a repeated process. Here are some vocabulary terms that you need to know. So as I said, compound interest was interest computed multiple times, more than once. Annually would mean that it would be computed every year. Semi-annually would be computed twice a year, usually every 2 quarters, which brings me to quarterly compounding, which is every 3 months, every 3 months. I'm just noticing a typo in this. It should be every 3 months. Okay. So here's an example. How much interest would 1,000 earn in 1 year at a rate of 6% compounded annually? So compounded annually, so that's going to be key. This is compounded annually. Okay, so let's find our rate first. 6% is going to be 0.06, because remember, percent is out of 100, so it's 6 out of 100, 6 hundredths. Okay, our simple interest formula, I equals PRT, principal times rate times time. So now our interest is going to be equal to the principal, which is the 1,000, times our rate, times our time. Now our time in years, how many times is done once a year? When you multiply this out, you get 60. So there'd be $60. So he says, what would the new balance be? So this is $60 would be the interest. So to figure out how much is in the account, I have to add what it started with. So I add 60 plus the 1,000 I started with, which gives me $1,060 in the account. Okay, let's try another one. As always, pause this, read through it, try it on your own first. All right, so same basic idea. We have $1,000 being put into this account. The interest is still the 6%. This time it's compounded semi-annually, which means twice a year. We want to know what her balance is after 1 year. So we're going to do the same thing. Okay, again, we have our rate is 0.06. Our principal is this 1,000. And we're going to do simple interest. So we're going to take our interest. We start out with $1,000. Principal times the rate times the time. Ooh, so we got to figure out what time is, right? This is different. 6 months, which is 1/2 a year. I like to use fractions. You can do 0.5, but don't be afraid of fractions. 1/2 of a year, right? 6 over 12 is 1/2, or 6 months is half a year. So now this is going to be times 0.5, which gives me $30. So $30 in interest after the first compounded computation. So $30 in interest plus 1,000. So my new balance is going to be $1,030. Now, but because I want to know how much after a year, I still have to do it for a whole year. I've only done it for half a year. So I have to do this process over again. So now my new interest is going to be my new balance times my interest rate times how many times it's compounded. So 1/2. When you do this out, you're going to get $30.90. So now, notice it's not the same, which is what the whole thing of compound interest is. It keeps compounding. The more you have in, the more interest you're going to make. So now my new balance, the balance after a year, is going to be this $1,030 plus $30.90. So I'm going to get $1,060.90. That's how much money is in the account after a year. Now, if it was semi-annually, as it is here, for 2 years, I would repeat this process, taking my new balance here, doing it one more time, then taking that new balance and doing it again. If it was for 2 years, okay? In other words, 2 years means he's going to compute it 4 times, but it's twice a year for semi-annually. Okay, be prepared to understand that, because your homework questions are going to incorporate things like that. All right, let's check the next example. Make sure you read through this, pause this, and try it on your own before you listen to the video. All right, so now it says how much interest, so we're looking for I again, does 1,000 earn in 3 months. So my principal is 1,000. In 3 months, this is going to be my time, and interest rate is going to be 6%, so this is my rate. Compounded quarterly. All right, so first I'm going to take my rate. Again, it's the same 0.6%, or 6% is 0.06. I know my principal is 1,000. That's how much money I'm starting with. And then my time. Now, time is going to be 1/4, which is 3 months. So 1/4, quarter of a year is equal to 3 months, which is equal to 0.25 years. Okay. You could also think of that as a quarter of a year is 1/4 of a year, which is 0.25 years. Okay. So now I have my time. Now I'm going to use my interest formula. Principal times rate times time. So my interest is going to be 1,000 is what I start with. My rate is 0.06. My time is 0.25 quarterly. If you do this out, you're going to get 15. So he's earned, or they or you have earned $15 in simple interest. Now I want to know what's principal after 1/4. So I've calculated 1/4. So I'll add the 1,000 to that. And this is how much money after a quarter. If it said how much, so 3 months is 1/4. If it said like 6 months, you would take this new balance and you'd repeat the process. If it said a year, there's 4 quarters in a year, so you do this 4 times. Okay, if it said 2 years, there's 8 quarters in 2 years, so you can do this 8 times. As you can see, this is getting pretty tedious to figure this out. You're either going to want to shorthand it, which will be coming up, with like a program, which will be coming up in a couple examples here. Or maybe if you have a quicker way of doing this, a different formula, which is coming up in the future. So, for now, let's look at example 4. All right, same thing. We're kind of comparing all 4 of these examples, which is why we're using the same numbers. Principal is 1,000, the rate is still 0.06. This time we're compounded daily. So what does that mean our time is going to be? Every day, so 1 day, which is 1 out of, assuming there's no leap year, 1 out of 365 years. Okay? That says, what is the balance after 1 day? So I only have to do this once because my time is 1 day. So interest is going to be principal times rate times time, which is 1 out of 365. So after a day, the amount of interest is going to be, when you round it in your calculator, or round to the nearest cent, because that makes sense, money here, is 0.16, so 16 cents interest. So how much is in the account after 1 day? $1,000.16. That's how much is in the account after 1 day. If this said 2 days, we'd repeat this process one more time. If it said 3, we'd do it 3 times. 4 would be 4 times. 50 days, we'd do it 50 times. If it said year, we'd do this 365 times. And who wants to do this 365 times, right? So that's why we're going to use a spreadsheet to kind of shorten this, or maybe a new formula. And speaking of spreadsheets, example 5 is going to incorporate a spreadsheet. It's not as, the process isn't as repeated as much as what I've said in talking about the previous examples, but you'll still get the point of how you'd use a spreadsheet, hopefully. So here's example 5. Read through it and try it on your own. All right, so I'm going to try to transfer all this to an Excel file. So you're going to have to pause this in between because I'm going to go through this relatively quickly. Here are all the categories that you need. Date, what balance starts at, deposits, withdrawal. This should look familiar because this is very similar to what you get from a bank statement. Okay, the new things that we haven't seen of these last ones. These principal and days interest rounded. Okay, so the first thing, if you were to refer back to the problem after you fill out all these, if you were to look back at the problem, it says the opening balance was $1,234.98. So for the first day, I'm going to start this day with $1,234.98. Now, if you remember Excel, you can click on these files, these cells, and you can make them money by right-clicking and formatting cell. And we want number, 2 decimal places. Let's see if we have currency here. Yes, currency with 2 decimal places. Okay. All right, now it's going to put it with all the dollars and dollar signs and decimal places. So that was the opening balance. Now, deposits. It says, let's see what Jennifer did. She withdraws 200, she receives 34, and she deposits 345. So she received 34. So altogether, she's only receiving $34 there. Her withdrawals says she withdraws $200 for that day. So $200. Okay, and then it says on July 12th, she deposits $345.77. So we filled in all that information that they've given us. And we want to find what her balance is at the end of the day on July 12th. So this ending balance of the 12th. So this principle used to compute interest, we have to take the opening balance, and these signs kind of give it away or help you out, plus how much money added to account minus the amount of money subtracted from the account. And that's your new principle used. Now this says days interest rounded to the nearest cent. So this is going to be our simple interest formula right here. The interest, so I equals the principal, this cell, the new principal, times, which is that little asterisk, the little rate, which if you look back at Jennifer's example 5 is 3.2%, which is 0.032 times time. Now, once. we gotta look to see what our time is. Okay, so our time is going to be 1 over 365, which is because it's computed daily. We enter, we get 9 cents. So that's how much interest was earned. So the ending balance now, this is going to equal the principal plus the new interest. That's our ending balance, which is what our opening balance is going to be for the next day. Okay, it says she doesn't do she has no withdrawals this day. So now we have to compute the principal. If I copy this over here, it should copy the formula. And it did. So I didn't have to do that again. Now same thing here. If I copy this, it should do that here. And it did. So this day is now, if I copy this here, it should do all the math for me. Now, if you didn't enter the equations and you just did this in your head, that's not using the power of Excel. Okay, because I can keep going on. I can do the 13th, the 14th, the 15th, the 16th, just by going like this. Copying this and going, let's see, look, it'll compute it as the days go on. So 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd of July. It's computed all the way through the 22nd of July. Okay. The only thing is this is if you deposited 345.77 every time. If you wanted to not do that, you could do copy this here. We're gonna pretend like we don't have any. This is if we don't have any withdrawals or deposits. Okay, so if I don't do any more withdrawals or deposits, I can figure out what I would have in my account a certain amount of days on. So by this day, I would have earned about $1, almost 50 cents, $1.49 that many days from this day. Okay, obviously if you add more money, which is another thing you could do. Let's say I want to know what I'll have if I add 1,000 every day. Okay, so I'm going to add 1,000 every day. So if I add 1,000 every day or every month or every year, if my time was in those things. Look at this, if I had 1,000 every day, and my account's so huge, it won't even fit in this cell. Let's see how big it actually is. 14,000. Okay? So if anybody's interested to know how much they need to save up, this would be a great tool to use it. Alright, once you do any questions with Excel, I want you to print out those and hand them to the homework. All other homework should be done, unless there's a chart, in Brainline. Okay? So you're ready for this homework. Good luck.